So today we are going to look at the integration or the functions of sine inverse of x, tan inverse of x, and natural logarithm of x. So let's start with the integration of sine inverse of x. Solution. So this also involves the integration by parts. So let u is equal to sine inverse of x. Sine u is equal to x. Therefore, dx equals to cos u du. dv is equal to dx. Hence, v is equal to x. From the integration by parts formula, we have integral of u dv is equal to uv minus integration of v du. In our case here, what we have here is that u is equal to x and the v is equal to x. So let us plug this value into our integration by part formula. We have integral of sine inverse of x dx equal to uv, which is equal to x, sine inverse of x minus x dx over cos u. Note that sine squared u plus cos squared u is equal to 1. Therefore, in our case here, we are having sine u is equal to x. Sine u is equal to x. And from this relation, we can make sine u the subject of the formula. So, sine squared u is equal to 1 minus cos squared u. Therefore, sine u is equal to root of 1 minus cos squared u. However, cos u also cos squared u is equal to 1 minus sine squared u. Sine u has been given as x, so we shall let that cos. This should be cos u. Therefore, cos u is equal to root of 1 minus x squared. Therefore, our integral becomes x sine inverse of x minus x dx all over root of 1 minus x squared. This is equal to the integration of sine inverse of x. Therefore, the integral of sine inverse of x is equal to x sine inverse of x minus integral of x dx over 1 minus x squared. Now this is equation 1. We are going to do here to solve this by substitution. Hence we are having the integral of sine inverse x equals to x sine inverse of x minus when we simplify this, we come to the conclusion that it becomes root 1 minus x squared plus a constant. Let me solve this. This is the conclusion, but let me concentrate on this. The integral of x dx over 1 minus x squared by substitution. Let theta is equal to 1 minus x squared. Therefore, if theta is equal to 1 minus x squared, therefore d theta is equal to minus 2x dx. Therefore, negative half theta is equal to x dx. Therefore, the integral of x dx over 1 minus x squared equals to negative half d theta over root theta, which equals to theta times half. When you simplify, you get this is equal to root theta. However, theta equals to 1 minus x squared. So the integral of x dx over root 1 minus x squared equals to 1 minus x squared. This is how I have obtained this, because when you compare this one come here, here, this is how I have got this. This is how I have got this. This was the simplification, the solving of this integral. This is how I've obtained this. Therefore, the integral of sine inverse of x dx equals to x sine inverse of x plus x squared plus a constant. Second one, I've got the second one is the integration of tan inverse of x dx. Solution. We solve this also by parts. Let u is equal to tan inverse of x. Therefore, du equals to 1 over 1 plus x squared dx. dv is equal to dx. Therefore, v is equal to x. From the integration by parts formula, we are having integral of u dv equals to uv minus integral of v du. Therefore, integral of tan inverse of x dx equals to x tan inverse of x minus integral of dx over 1 plus x squared. Therefore, the integral of tan inverse of x dx equals to x tan inverse of x minus tan inverse of x. The last one, integral of natural logarithm of x dx. Solution. Let natural logarithm of x is equal to u. Therefore, du is equal to 1 over x dx. dv is equal to dx. v equals to x. So from the integration by parts formula, that is integral of u dv is equal to uv minus integral of v du. Therefore, integration of x dx equals to uv x in x minus integral of v du minus v du, which is equal to x times 1 over x dx, which is equal to x in x minus integral of dx, which is equal to x in x minus x plus a constant. For the integral of x tan inverse of x dx. Solution. Let u is equal to tan inverse of x. Therefore, u is equal to 1 over 1 plus x squared dx. dv is equal to x dx. v is equal to half x squared. Therefore, the integral of x tan inverse of x dx equals to half x squared tan inverse of x minus half integral of x squared over 1 plus x squared. Therefore, it is equal to half x squared tan inverse of x minus the half integral of x squared over 1 plus x squared dx, which is equal to half x squared tan inverse of x minus half integral of 1 over 1 plus x squared minus 1 over 1 plus x squared dx. Here, this is the result of wrong division because you divide this one, the numerator over denominator. As a result, you have this, you have got this. Alright? So, which is equal to half x squared tan inverse of x minus half integral of 1 over 1 plus x squared dx plus the integral of dx over 1 plus x squared which is equal to half x squared tan inverse of x minus 1 half tan inverse of x plus half tan inverse of x plus a constant. Therefore, the integral of x tan inverse of x equals to half x squared tan inverse of x minus half tan inverse of x plus half tan inverse of x plus a constant.